appreciate the famous French geometer Rene Descartes. Although many of you may not know Descartes, you would all recognize him through his works as a mathematician. Descartes is the founder of analytic geometry, which is just a fancy way of saying the visualization of algebra through geometry. Lying in bed one day, he was looking up at the ceiling, and he saw a fly. He wanted to be able to pinpoint the fly's exact location through numbers. He did this by counting over the tiles from the wall to the fly. This was the foundation of the Cartesian plane, which you would know as the coordinate plane. In fact, many of Descartes' great ideas came to him while lying in bed, seeing as he never got out of it before 11. This tradition started as a young boy at the College of Henry IV, where he spent 7 years from the age of 8 on. He continued this as he went on to study the law at the University of Poitiers and for most of his life. While still at the university, Descartes joined the army for a short period of time. While in the army, he met the famous the philosopher and scientist Isaac Beckman. Isaac urged Descartes to devote his studies to the mathematical approach to nature. Descartes also credited a series of 3 powerful dreams with determining the course of his studies for the rest of his life. Descartes was not only a great mathematician, but also a philosopher. He's often referred to as the father of modern philosophy. Even though his time period, being born in 1596, may not seem very modern to us 21st centuryers, his thinking was far ahead of his time. Enough so that Pope Alexander VII added his books to a list of the index of prohibited books. One of Descartes' major philosophies was his systematic process of Cartesian doubt, which involves doubting everything one believes in order to determine what is really true. Descartes famously stated, "I think, therefore I am," which comes down to the act of doubting one's own existence arguably serves as proof of one's own existence. Another mathematical contribution from Rene Descartes is coming up with the use of superscripts to express exponents. We all see this in our everyday world as the little number after and slightly above the number it is a power of. Here we can apply Descartes' works to problems similar to what we have worked on this year. Here we have a Cartesian plane. Using the distance formula, we can determine the distance between these 2 points. The distance formula is d equals the square root of x2 minus x1 to the second power plus y2 minus y1 to the second power. And plugging in our points, that would look like this. And then 2 plus 2 would be 4, and 2 plus 3 would be 5. And then 4 to the second power would be 16, and 5 to the second power would be 25. And then 16 and 25 would be 41. And then that would be about 6.4. So the distance between this line, or this point, and this point on this line would be about 6.4 units. Using the midpoint formula, we can find the point that is in the middle of these 2 points. The midpoint formula is x2 plus x1 over 2, comma, y2 plus y1 over 2. And then putting in our points, it would look like this. And then 2 plus negative 2 would be 0, and 2 plus negative 3 would be negative 1. And then it would just be 0, and then negative 1 over 2, which would be negative 0.5, which on the plane would look right about there, which, as you can see, is right about in the middle of the 2 points. In the video, I talked about Descartes' use of superscripts to express exponents, which would look like that. And 26 to the third power could also be shown as 26 times 26 times 26, or 17,576.